detected because of a chance alignment of Earth and a solar system 63 light-years away that astronomers refer to as HD 189733. The Hubble and Spitzer space telescopes together caught a planet whipping around this star once every 2 Earth days. This is one sizzling planet, with surface temperatures up around 900 degrees Celsius. The planet, tagged HD 189733b, is so hot that a vapor trail follows in its wake. Starlight passing through this trail allowed scientists to detect carbon dioxide, methane gas, and water in the atmosphere of the planet. Then there's the Sun-like star HD 209458, visible with binoculars 150 light-years away. It has a planet known as a hot Jupiter. It's hot because it's close in, as near as 7 million kilometers from the star. Compare that to our planet Mercury, 46 million kilometers out from the Sun. Or the Earth, 146 million. Scientists estimate that stellar winds are blowing some 10,000 tons of material every second off the surface of this hot gas giant. How long before it gets reduced to just a shriveled core? That's just what happened to the star called Corot 7. Astronomers spotted a planet slightly larger than Earth and just about as dense. But because little Corot 7b is so close to its parent star, it's most likely covered in molten lava. If these planets are too near to their stars to harbor life, many of the others discovered so far are too far away and too large. Like the one orbiting a star the ancient Arabs called Fomalhaut, meaning the mouth of the fish. It's just 25 light-years away and was the first exoplanet to be seen directly. Using Hubble, scientists blocked out Fomalhaut's glare and found a planet orbiting about 10 times farther out than Saturn. It would take 872 Earth years to make just one orbit. The brightness of this planet suggests that it's huge and probably surrounded by a dusty disk. Astronomers are seeing hints of the diversity of worlds imagined by the ancients, but still only scant evidence of anything resembling Earth. Still, there's one class of stars that, until recently, had been overlooked. The M stars are the most numerous in our galaxy, around 76% of the total. They're often called failed stars, because not enough mass fell together as they were forming to fuel the intense nuclear fusion that burns in stars like our Sun. To be in the life zone of one of these dwarf stars, a planet would have to be very close in. Unfortunately, because these small stars spin very quickly when they're young, they're like electrical dynamos with intense magnetic fields that generate dangerous flares. If a planet manages to survive these blasts, it may have to endure another handicap. In close like this, it's likely to become gravitationally locked to its parent star, just like our moon is to Earth. With only one side ever facing the star, one side scorched, the other frozen. Is there any hope? On Earth, we know that the unevenness of solar heating, due to the day-night cycle, leads to oceanic and atmospheric circulation patterns that redistribute the heat and equalize temperatures. A computer simulation performed by NASA scientists showed that a tidally locked planet could, in fact, develop circulation patterns like this. In the computer model, a cloud cover developed on the light side, keeping temperatures down and air pressures high. The result? Winds that circulated the planet, redistributing enough heat to keep the rate of freezing down. That's one reason these M stars are on Planet Hunter's radars these days. Another reason is that planet hunting itself has taken a leap forward. An instrument that specializes in looking for solar wobbles has come online. HARPS, short for high-accuracy radial velocity planet searcher has been on a planet-finding tear. At a recent conference, scientists announced 30 new planets discovered with this instrument. Among its most promising targets, Gliese 581, that inconspicuous red dwarf in Libra. 4 planets have been detected so far. Planet E is the lightest exoplanet discovered to date, just less than 2 times the mass of the Earth. But it's so close to its parent star that its orbit takes only 3.15 days. Planet B is close in too, and weighs 16 times what Earth does. Planet C, at 5 Earth masses, lies just inside the habitable zone, while Planet D, at 7 Earth masses, lies on its outside edge. To find out what direction these planets might have taken, scientists have sought to model their early evolution. Planet C, on the inside margins of the life zone, would have immediately been subjected to a withering barrage of solar radiation. Think Venus. Any water vapor in the atmosphere would have been stripped away. Gases spewed out by volcanic activity would have turned the atmosphere increasingly dense. A strong greenhouse effect would have turned Planet C into a hothouse. Planet D is different. Earthbound instruments show that its gravitational pull is surprisingly weak, meaning it's not very dense. That suggests that it might have migrated in from the outer parts of its solar system, carrying with it significant amounts of hydrogen and oxygen. It could be a water world, with an abundance of vapor in the atmosphere that would strengthen its greenhouse effect. Of course, there are still many unknowns. Is it far enough out to avoid becoming tidally locked? If it is locked, has it developed circulation patterns strong enough to keep the freezing down on the dark side and support a habitable climate? Astronomers will continue to study the planets of Gliese 581 in the years to come, as part of a rapidly expanding list of targets. The next era in planet hunting is now ramping up with the recent launch of the Kepler planet-finding spacecraft. Kepler amounts to a huge digital camera in space, pointed at a region containing more than 100,000 stars. Its designers are betting that some of those stars have planets, and that a fraction of them are tilted so that their planets pass between their stars and Kepler's camera. If so, astronomers will detect subtle dips in the brightness of these stars by as little as 1/100%. That's the signature of a planet passing in front. Another project is breaking new ground by combining data from several ground-based telescopes. Astronomers recently used them to probe a star called 61 Virginis, 28 light-years away. It's nearly identical in mass and age to the Sun. What's more, it was here that astronomers found the first Earth-like planets around a Sun-like star, at 5 and 7.5 times the mass of Earth. A simulation of the atmosphere of the larger one, picturing its flow of heat on a global scale, shows how much we can understand even at this distance. How long before a truly Earth-like planet is discovered? As astronomers' instruments get better, and their techniques more refined, it's likely that they'll uncover smaller and smaller planets. For now, though, the rare Earths hypothesis may well have the edge over many worlds. The conditions that nurture a habitable planet seem hard to come by, such as position in the life zone, a nearly circular orbit, and magnetic fields. The threats are many. Solar flares, marauding giant planets, tidal locking, and other lurking catastrophes. In fact, nature has handed us a paradox. Medium-sized stars, like our Sun, turn out to be remarkably hostile to life. They emit barrages of ultraviolet radiation and solar outbursts powerful enough to ruin a fledgling atmosphere. And yet, somehow, we manage. So, if it turns out that the Milky Way is filled with habitable worlds, it's not that the galactic real estate is so special, it's that life finds a way.